All right. Thank you everyone for joining us today. I'll get started with the introductory portion of the webinar, and then we will be accepting live questions today on the topic of open pit closure. We have a great panel here today of experts that are excited to field those questions and have a great discussion with you all today. So this is an interactive webinar. We call them Ask the Experts, and it is associated with one of our online courses, which is titled Fundamentals of Open Pit Slope Design. It is the final webinar associated with that course, and the topic is on open pit closure with regards to open pit slope design. So planning for open pit closure within your design. And this webinar is put on by the Geotechnical Center of Excellence. If you are unfamiliar with us, we are an industry-funded and member-led center. We are focused on producing practical geotechnical research and education. We do this by collaborating with industry in order to bridge gaps that we identify within geotechnical research and education and fields of study. We'd be happy to talk to you more about the GCE. You can reach out to us at any time at gce@arizona.edu. And the GCE is supported by our members. We have all the members that you see here on our screen are part of our membership group, ranging from our executive members to our leadership, partnership, and patron members. We appreciate all of them. They are the ones who make it possible to put on webinars such as this webinar and to develop courses and perform research and do all of the work that the GCE does. So thank you very much to all of our supporting members. And as I mentioned, this webinar topic aligns with one of our professional development courses. So just to give you a bit of more information on that, it is the Fundamentals of Open Pit Slope Design course, which was a new course in 2024. It spans across many topics, all relating to the fundamentals of open pit slope design. You can see them listed here. And today we'll be talking about the final topic, which is open pit closure. We are starting a new session of this course. The 2025 session will begin in September, and it is currently open for registration. And you can email us for more information or scan the QR code here. I'll show that again at the end of the webinar. And we'd also like to acknowledge the Large Open Pit Project, who not only developed the text that this course is based on, but also underwrote the course, the online course for the GCE. So thank you very much to LOP. They have a great series of textbooks, all dealing with large open pits. And if you're interested in looking more into those, you can visit lopproject.com. I will mention in just a moment, there is a new text that came out where two of the editors are actually on our panel today, and it is focused on open pit and waste dump closure. So that is now available. All right, it's my pleasure to introduce our GCE webinar team who's here today. Myself, I'm Jillian Noonan, Senior R&D Engineer with the GCE, and I'll be the moderator for today's session. Also with me assisting is Julia Potter, who's the director of the GCE. Julia, thank you.
Thanks, Jill, and thanks everybody for being here today. Looking forward to a great discussion.
And Cheryl Bukowski, who is our professional development program lead. Cheryl, thank you.
Thanks, Jill, and thanks for being here today.
And then we have an amazing panel of experts today who I will now introduce to you. We have first Phil DeGraff. Phil is the director for Giraffe Mining Consultants. Phil produced a module for the course on Introduction to Mine Closure. And as I mentioned, is also editor for the new Large Open Pit project text focused on open pit and waste dump closure. So Phil, we're really glad to have you here. I couldn't think of a better expert to join our panel for today's topic.
Thanks, Jillian. Looking forward to it.
We also have Jeff Beal. Jeff is Global Technical Advisor with Pateau Associates. Jeff has produced many course modules for the Fundamentals of Open Pit Slope Design course on various hydrology topics, as well as a primary presenter in one of our other online courses, which is the Water in Mine Operations and Slope Stability course. Jeff is also an editor for the new LOP project text, Open Pit and Waste Dump Closure, and has a wealth of knowledge on hydrology applications in the realm of mining. So, Jeff, glad to have you here. Thank you so much.
Thank you, Gillian. Glad to be here. Looking forward to some good discussions.
We're also very fortunate to have on our panel today Teo Costa. Teo is a geotechnical specialist with Vale, and Teo provided for the course a very interesting case study on the first Vale mine closure experience and the lessons learned there. Teo, we really appreciate your contribution to the course and for being on the panel today. Thank you.
Thank you, Jill. I'm glad to be here and hope we have some nice questions and very smart answers from this group here.
Thanks, Teo. Also joining today on our panel, we have Miguel Paganin Neto. Miguel is General Manager of Geotechnics and Hydrogeology with Vale. And Miguel also provided a very nice case study for us on the Gongo Soko open pit case history and closure project. Thank you so much, Miguel, for being here.
Thanks, Julia. I'm really glad to be here with you guys, and I'm certain that we have a very nice discussion today.
Thanks, Miguel. All right, and welcome to our attendees. Now I will give you just a bit of information on how you can interact with our panel today and ask questions. So firstly, this is a webinar, so that means you are automatically muted. Your video is off. You don't need to worry about those controls. If you have a question you'd like to submit for our panel on the topic of open pit slope design, closure planning, and considerations, you can enter it at any time during the webinar into the Q&A, which is a button on your control panel. If you click that button, it will open up a window where you can type in your question. Others can also see the questions that are posted, and you can enter your questions anonymously. If you see a question you particularly like, give it a thumbs up. If we have highly rated questions, we'll make sure to move those to the front of the queue. And lastly, we are recording this webinar. We will be posting it to the YouTube page. And just a quick disclaimer that all of the content herein is intended for educational purposes only. All right, I'm done with my intro. Is the panel ready for questions?
We are.
Yeah, sure.
Great. All right, well, I will welcome our attendees at this time to go ahead and start entering questions. And you can continue to do so throughout the webinar. We will run until 2 p.m. Arizona time, so an hour for the webinar. All right, so our first question. This one came in from one of the students in the course, and it was directed towards Phil. It is regarding your presentation. So Phil, if you wanted to start, I will first direct it towards you, and then we can open up to the rest of the panel because it is a general question I think all can contribute to. And the question is, if I recall correctly, Phil DeGraff mentioned in his presentation that designing for a mine life of around 200 years is a common range of time. The question is, does this time frame often vary much? And if yes, what is that variation usually based on? So Phil, would you like to start with this one?
Sure, that's a really good question. I suppose it's one of the questions that we grappled with quite a long time in developing the guidelines. So some pretty broad ranges of expected design lives have been published through different entities. I think the Atomic Energy Association are talking about something like 2,000 years. Dam closure in Alberta is looking at something like 1,000 years. We looked at those numbers, and then see even shorter numbers in the order of 60 years have been touted by some practitioners, but that would require an ongoing certification by a geotechnical engineer. We didn't think that sort of certification approach would be ideal from a mine owners or even a regulator's perspective, because you don't have a lot of certainty in the longevity of a design if it has a 60-year warranty. So I mean, design life and warranty or guarantee are somewhat synonymous terms, because your design life is basically the period that the design is expected to be serviceable with minimal maintenance. So after much deliberation, we landed on a number of 200 years as a defendable number that you need to rely on some amount of engineering judgment, but there's some precedent that can support a 200-year design life. If you're trying to design for a 500 or 1,000-year design life, that's well beyond any precedent that engineering has been able to predict to. And even numerical modeling extending out to those numbers becomes really quite fictitious or fanciful. So 200 times we've landed on that as a number that is in other stakeholders, as well as having a good amount of reliability in your forward prediction of serviceability. Thanks, Gillian.
Thanks, Phil. You were slowing down, speeding up just a bit as far as maybe your bandwidth goes. Most of it came through though, to be able to understand your answer.
Yeah, I think just to jump in here, this is Jeff. So as Phil said, we went round a little bit in this with the development of the closure guidelines in the new textbook, and we landed on 200 years for a couple of reasons. Firstly, that is, as Phil said, about as much experience as any engineering projects has ever had with closing slopes or lakes or any kind of large facility. Secondly, the second reason is 200 years is a long time in the way technology progresses, and so in 200 years' time, there'll be different technologies, different concepts available. And so it's not really realistic to look at things now and think that status quo is gonna change for 200 years. And then the third reason was the regulatory bodies and the government bodies themselves. If you look around, there's very few regulatory bodies that have lasted for 200 years. So it's really kind of, if you go longer than 200 years, the history is that politics and regulations change within that time. So that's why we landed on 200 years. And the way I look at it is, and I've said this in various meetings to various regulators, if you go for longer than, so somebody said, why don't you go for 400 years to me once in a meeting? The regulator said that in the meeting. So I looked at him and said, do you realize that's like Henry VIII? That's like asking Henry VIII whether he wants an iPhone 14 or an iPhone 15. Things move on, and so the technology will move on, regulations will move on, and so we just landed on 200 years as something that was not too short for engineering, but not out of the realms of reality.
Great, good explanations. I'll ask Teo or Miguel if you have anything you'd like to add.
Yeah,
I can go ahead, Miguel.
Go ahead. Miguel, go ahead.
I just would like to complement, for example, the planning of hydraulic structures, for example, for waste pile or for open pits. With the climate change, maybe we should consider a time bigger than 200 years for this kind of design. But I totally agree with Jeff and Phil that I also believe that 200 years it's a very good range of time for this planning. But just to consider for the hydraulic structures of waste pile and open pit, that with the climate change, it's a point to I don't know, maybe make a deep dive.
Yeah, I think you have to look at it on a case by case basis, and you know, just along that, you know, there's some pit lakes that we're involved in where they're going to take more than 200 years to stabilize and recover after mining. So you do have to look at it on a case by case basis for sure. So yeah, so you know, in some cases, you know, 200 years maybe maybe too short, but flipping that the other way around, I mean, I've done 3 underground closures in Europe in the last 10 years where we've achieved regulatory sign off and walk away in less than 10 years. So it just depends on the site.
Yeah, my question is just going straight to the side. Depends of the site because we have some areas that there are dams and waste pipe just below, and hydraulic connection with the slopes from the mine above. And for waste piles and for dams, we can life of the structure for 1,000 years or 500 years. So we have to check if what we have with a hydraulic system that come to 100 years to 1,000 years in above. So we are pushing for the regulators in order to solve this type of incoherence. So it's a case to case study.
Actually, that's a really good point, Tio. I suppose that needs to be agreed with the stakeholders because the longer the design life, the more conservative the design will need to be. And I suppose it's if you have a shorter design life, then you are committing to have more maintenance. But that's
Yeah.
something that could be negotiated.
Yeah, the
Important
maintenance.
point.
Yeah, the maintenance thing is key, Phil, as you say, you know, and most hydraulic structures and most surface water designs fail not because of design, but because of lack of maintenance, and that's pretty much global.
Yeah.
And so if you're going to design for 200 years or longer than 200 years, then you need to have the maintenance program commensurate with that. And of
Yeah.
course, that takes some organization.
It is a cue point because it doesn't matter if you're using 500 years and 1,000 or 200 years. If you are using concrete, how long the concrete can survive in a acid rains and this type of environment. So if your structure don't support 100 or 200 years, it's not a closed system. So
Good point. I mean, that is a good point, Tio. I mean, in Nevada, for instance, they at one point landed on a closure period of 200 years because that was supposedly the design life of HDPE, an HDPE liner, and obviously liners are key for closure. So that was landed on Nevada, but I think, you know, now we see what happens in reality. We would shorten that a little bit.
But Jeff, remember we were involved in another project with a liner that's already failing in less than 5 years. So
Yeah. Yeah.
different problem. Different. This is different point. It's another different point.
All right, thanks, guys. We're already off to a really great start with our discussions, and I just want to remind those in the live audience we'll be going for another 40 minutes with this webinar, and that we welcome you to, at any time, submit questions that you have for our panel today on the topic of open pit slope design, closure planning, and considerations. To continue on with the great discussion, I'm going to pull up another pre-submitted question that came in through the course site. Talking about balancing short-term operational goals and long-term closure objectives. So this was a lot. It was for the not anyone specific on the panel. So I'll read out the question, and then if anyone would like to volunteer to go ahead and start off, I will take a volunteer. So the question is, what strategies have proven most effective in aligning short-term operational goals with long-term closure objectives, especially in multidisciplinary teams? So I know we have Jeff and Phil, who do a lot of consulting work. We have Teo and Miguel, who do work within Valet. Would any of you like to
Yeah,
start?
so I mean that is also a really good question, because that is something that minds grapple with all the time, is trying to balance short-term gain with long-term planning. And you know, if you don't start with the end in mind, and if you don't think about closure during operations, you may be left at the end of the mine life with a lot of work to do for closure. And conversely, if you do think about closure all from the get-go, and if you do think about closure all the way through operations, and you can close things concurrently, then the cost burden and the burden of technical work at the end tends to be that much less. And so there's a couple of good examples of this. So I was involved with a due diligence team last year looking to purchase it was a tier one mining company looking to purchase a site from another large mining company. And the reason that they didn't purchase the site was because they thought there was too little concurrent closure work, and therefore the long-term closure cost and liability was too great. And so they ended up buying a similar site which had done concurrent reclamation and had thought about closure through operations. And so the burden at the end would have been much less. So, you know, it's always tempted to, you know, for the general manager or for the engineering staff to look at short-term operational gains, and but you know, there's a cost of doing that. And you know, I think the mining industry sometimes shoots itself in the foot with the 12-month KPI. So if you put general manager or senior staff or engineering managers on 12-month KPIs, that's what they care about, and it's very difficult for them to go to spend money on something which is way beyond their KPI timeframe.
Yeah, I think that the common thing across different multidisciplinary teams is cash. If you can do the cost calculation on concurrent at the end, the cost of concurrent remediation will win every single time. So I think that's probably the easiest way to get that message across. But like Jeff was saying, if the KPIs are skewed towards the short-term wins, it's going to be a much harder conversation. But I think this is one of those things that it just takes persistence. You know it's the right thing to do, and keep knocking at the door and putting the evidence on the table. I think the counter argument is always going to be there might be another pushback, or a gold price or platinum price might go up, and then all that concurrent remediation is now defunct, and you have to mine out those waste dumps that you've spent a lot of money rehabilitating. But certainly on the balance of probabilities, I think if you look at things from an economic basis, there should be a good justification for it. And a lot of operations are thinking about geomorphic waste dump design for closure. And you have to start with that end point in mind when you start dumping to a geomorphic waste dump geometry. So those are other reasons for getting the closure vision in right at the beginning of the mine development plan, so that vision is completely aligned. The closure vision and the operating execution, they're not pulling in opposite directions.
Yeah, and again, one of the things we've tried to bring out in the book is you know, closure planning and how you approach closure is very, very site specific. And so, you know, some sites you need to do rigorous closure planning and concurrent reclamation, but perhaps on other sites where closure is easy, you don't need to put so much long-term planning in it. But having said that, you do all the way through the operations need to have a vision for what you're trying to achieve for the land and for the land use after the mine has gone. That vision really needs to stay with company management and mine management all the way through the operations.
I agree with Jeff and Phil. I also believe that it's a case-by-case study. But in the book, for example, we have a very nice case, the Gongo Soko pit, with the consequence of not implement, for example, progressive mine close planning. And in this case, for example, we did, as Jeff mentioned it, the 12 months. And in the end, one day we just arrived in the end of life of the mine, and we didn't align it, the consequence in the past. So as Phil mentioned it, I believe it's a, how can I say that? It's a way to show, to demonstrate the cost consequence of progressive mine planning in a scale of time. It depends of case by case, or do not implement it in any case or in the end of the mine. And in sometimes it could be like very expensive. So I believe it's the way to do it.
Yeah, Miguel, Gongo Soko is a good case study on that for sure.
Yeah, I
Don't
think
leave
what-
everything to the end. Yeah. Sorry,
yeah,
Tio.
yeah, and we are doing all the same in our mind because we are fixing the plane during the fly. The mines are quite old. They are prepared not for close. The slow safe it's very low, not prepared for long-term safety. So how can we change in the middle of the life of mine? Increase the safe factor in order to reach the long-term stability. So we are trying to engage the miners, the planners, in order to have this really long-term view of the mine. But it's quite difficult because people in the mine are focused on operation. They are struggling to dig the ore, so it's difficult to show this vision for people who have this type of short vision. So that's the reason we are still spending a lot of money as we did in Gogo Soko or even Aguas Claras. So for now, we still struggling to have some strategy that could be effective to bring the short term to show to the short term team our long term vision in order to prepare now for closer. So I think we don't have a strategy at all. We are still looking for how to engage these guys and how to show if you spend cents during the mining operation, we will save billions. That's what we are spent in order to solve the problems that we have built during the life of mine.
I think it's quite important to have a robust change management plan then. So if an operational design is going to have a material impact on the closure plan that's agreed, then that obviously requires a detailed risk assessment and approval from GM or higher. Like you say, Tio, if those cost implications are going to be significant for closure, even if it's 10, 20 years down the line, that requires a pretty high level of sign-off, but that requires a proper management of change for these operational design changes, which sometimes just happen very quickly overnight.
Yeah, it depends of this point is very associated with the world mine crisis. If you are what you call mining crisis, we don't have this small money to spend looking for the profits in the end of the mine. So we have to balance, to try to establish a balance between what we can do now and how much we can do now in order to save the money in the future. You're right,
Yep.
Phil.
And I'll agree that both of those case studies were really great, showing how Vale handled those closures. So we really appreciate that you guys put that information forth to benefit the students and the public. So thank you very much for sharing that information. They are very good case studies. Any more comments on this question? We do have a live question that came in, switching over more to the topic of talking about balancing stakeholder expectations with geotechnical realities. Any final comments here before I pull that one up? All right, and just to let everyone in the webinar know, we're about halfway through right now, so about 30 minutes left. And I want to thank our panel already. You guys are great. And here is our next question. So this came in through our live group asking for the panel, how do you balance stakeholder expectations with geotechnical realities when you are defining post-mining land use, or PMLU, and or design acceptance criteria, or DAC? So this was not directed at anyone specifically. Would anyone feel inclined to start off?
Yeah, I'll give it a shot. I mean, again, it's very site specific. I think in terms of geotechnical realities, and particularly for open pit closure, the place to start always is to look at the final pit water balance. And few things to look at. Firstly, where will the water and the pit lake recover to? Because anything that's underneath the pit lake has less geotechnical consequences. So you're really worried about the slopes that remain above the pit lake. Secondly, how long will it take to get there? I mean, as I said earlier on, some of the pit lake predictions that we're looking at in desert environments take many hundreds of years to stabilize. So essentially, you have to look at that as a permanently exposed pit slopes. And thirdly, you look at the water quality. If the water quality is good and the geochemistry of the wall rocks isn't too reactive, then you can tolerate a little bit more instability, because it's not going to do a lot of, or make a lot of changes to the pit lakes. So I think really the stakeholder expectations firstly need to be realistic, and there's always a balance with stakeholders. There's always regulators or even some government officers or MGOs which think that the site can be closed with land uses which are just not realistic. And so getting the reality and the site-specific nature of the closure plan right, or at least understanding the uncertainties from an early stage, is a good way to achieve the balance, to temper the stakeholders' expectations where need be, and to make a realistic closure plan based on the geotechnical and hydrogeological reality of the site. So again, it starts, with looking at the site of the whole and what can and cannot be achieved with the geotech, hydro, climate, geochemistry of the site. So look at those four things and see what is reasonable to achieve, and then build from there.
So this is one of those really difficult things that it starts to stray off, bridging the gap between social impact and technical engineering elements. And I suppose some of the projects I've been involved in the last year and a half, 2 years, the that's been the hardest part, is that acceptance of design of the closure vision. Trying to get acceptance of the closure vision at the end of life is a very difficult conversation to start having. Those conversations should have happened before the mine even started, and agreeing on what that closure vision might look like at that point. Because if you only start engaging late in the plan, the other stakeholders, non-mining company, the regulators, and other key stakeholders start to feel that the design has been forced upon them. And it's some of these concepts are quite difficult for the layperson to understand, from a geotechnical impact of what is a factor of safety, what is probability of failure. That's not a conversation you're going to have with a stakeholder who hasn't finished high school in an hour or two. That's going to take a lot of time to socialize them on the principles on a really basic level, so that they can actually understand at a reasonable level what the residual risk might be for these different scenarios. But the closure guidelines don't go into the stakeholder engagement in a significant manner. But that is certainly I suppose, a vulnerability in many closure plans, that there's not enough early engagement with the stakeholders to work through what plausible post-mining land uses might be, and then understanding what those factors of safety and other geotechnical or hydrogeological, geochemical loadings might be post closure. So it can get quite emotive, and certainly, I'm repeating myself here, but getting the stakeholder engagement early in the piece must be the practical way forward.
Just to complement, I would like to give, for example, our example here in Vale and in Brazil, complementing Phil and Jeff. I also believe that it's a site specific. Here in Brazil, for example, we have a lot of specific regulation regarding dams. So when we are defining post-mining land use, in a hand, we have, for example, the C-level of the company, investors, managers defining, for example, targets regarding cost, regarding like economic perspective. On the other hand, we have the technical team regarding safety factor, water quality, exit drainage, dams, progressive mine closure, etc., etc. And here in Brazil, we have a social perspective, the community and the Brazilian regulation regarding what we are using, for example, for what we are doing for the post-mine land use, and trying to understand our design acceptance criteria, for example, for the pits. What we are doing here, we are putting everybody on a table and we are discussing, trying to find a middle point for everyone, because it's very hard to find a middle point between the C-level of the company, social perspective, and the technical team. But we are trying to find this, and until now, it's the best way we found to balance like stakeholders' expectations here in Brazil and for Vale.
Yeah, pushing this middle point in terms of GAC, we here in Brazil, and as you're able to see in the mine closure guidelines, we're pushing to control this post-mine stability, not focus on DAC, focus on performance of the structure, dam, waste pile, or open pit. The same effect, the FOS, the POF could still be a guide, but what defines the quality and the longevity of the structure should be the performance. So based in monitoring, in visual evaluations. We not lose slope stability analysis and give FOS or POS. We're still using this, but not as a main guide for the quality and the effectivity of the slope or dam, this type of thing. So we have to change this expectation from the regulators, from the third part that expect for us a safe factor of 1.5 or 2 or some crazy things like this. So let's give to the community a stable area, long term with a long term stability, greeny, revegetate that the community can use as they have to use for long years. So we are trying to take out the focus from the DAC, mainly POF and FOS.
All right, sorry, I had to find my unmute button there. Thank you, everyone, for the good discussion on this question. Thank you for the question to our live group. We have received another question that I'll pull up, but first I'll ask the panel any additional comments here. I think you did quite a good job discussing this topic.
No, but I mean, it's taken a long time to answer 3 questions, and that really illustrates the quality of the questions, actually.
All right, well, we have another good one coming up from our live group. Let's see. All right, so this one was submitted anonymously. The question is, and also again, just to the panel, do operators integrate geotechnical monitoring and performance data from active operations into closure planning? And I guess how? If yes, then how would you incorporate that into closure planning? So again, not directed to anyone specific. I know, Jeff, you're always a good volunteer to start, but I will ask the entire panel, would anyone like to start with this question?
So I'll jump in.
Okay, I saw Teo going for it too, but Phil, we'll give it to you. Thank you.
No, go ahead, Teo.
Teo.
Okay. Yeah, we have a really good team doing geotechnical monitoring in our group. So we have all these tricky things: INSAR, ground SAR, inclinometers, in piezometers, everything together. So we have a panacea of everything. Helps a lot to control the mining operation and keep the slope safety and people in the mine safe from any type of problem. And we are now trying to establish and to improve this type of monitoring in order to look forward, not to be reactive or what we call operational monitoring. Now we're trying to do what we call proactive monitoring, and it could be used for mining closure. But when we talk about mining, we cannot what mining closure. We cannot think about still there for long. And somehow we have to leave the place for another one. So in the last 10 days, the increase of INSAR use satellite image, we have in the last 10 years improved a lot this technology, and they prove to be very useful for, let's say, not intensive monitoring system. So we can leave the prisms, the ground radars, and use the INSAR monitoring for what we call long-term monitoring. So I think it could be a good way to integrate and use monitoring in looking for close plan and mine closures.
Yeah, I mean, benchmarking performance for prediction is a well accepted design methodology. And I suppose the challenge for operating pits is that the backward looking design lives or operating lives are not particularly long when we're looking at a 200-year design life. So there's quite limited legacy data available, and actually the guidelines called for developing a global repository of longevity performance of long closed design projects. I suppose one of the drawbacks or the tripping points that many operational geotechs land in is that we look at a slope or a dump performance over the last 5 or 10 years, and it performs really well. And then we try and forward predict that performance for 50, 100, and 200 years. So past good performance is not necessarily a good predictor of long-term forward predicting of good performance, but certainly if the last 5 years have been performing poorly, then almost certainly the next 5 to 200 years will continue to perform poorly. So there's a bit of a nuance in using slope performance for prediction, but certainly we need to get better at evaluating degradation or degradation susceptibility, and then actually measuring degradation over longer term so that those forward prediction models can be more robust. Thanks.
Yeah, I mean, the answer to the question is yes, absolutely. I mean, when you're getting towards closure, particularly for longer duration mine lives, you've got a hole in the ground, and you can see how that's performed. As Phil says, right, you're never 100% sure how the individual geotechnical units and slope orientations are going to degrade, but you know from operations and potentially from benchmarking other similar sites which units and which sectors are going to give you the bigger issues for closure. So really, I mean, it's the monitoring data you have and the performance data you have is absolutely vital as you go into closure, because it's you know, the pit has to stay. It's the same pit, and it has to perform. So, you know, so again, it's looking at how long the slopes are going to be exposed. The picture on the front of the closure book, for instance, that Gillian showed, that's a pit that Phil and I closed over the last 4 or 5 years, and we knew the slopes had some issues, but we knew those issues were going to be fairly short-term issues, because we knew the water level was going to go all the way back to the surface, and we were able to pump the lake full rapidly with nearby river water. So our geotechnical closure performance was very short, but we did have the you know, we'd operated the pit for 15 or so years, so we knew exactly where the problem areas were, and we were able to manage those during closure.
Totally agree with you guys. Nothing to complement. Estelle mentioned it. I believe it's a cycle. We use like the geotechnical monitoring, and we analyze like the performance of the structure to guide like the closure planning. So one thing depends on the other thing, so nothing to complement.
All right, thank you very much. And thank you for the question. As Julia just posted, we have about 10 minutes remaining. We did just get another live question in. Let me see if that's in our PowerPoint yet. Yep, there it is. So I will pull this up. So submitted by Sandy from our live group. Thank you for the question. So I'll read this through, and then we will open to the panel. So returning to the earlier question about design life, when an open pit mine is expected to close and transition into an underground operation, What are regarded as the best balance and considerations for the end-of-life design decisions for the pit and design life? In particular, how are trade-offs with stakeholders managed between more aggressive, cost-efficient approaches, for example, reduced maintenance and accessibility, versus more conservative, longer-term designs, especially when the final stages of the pit may naturally lend themselves to a more aggressive strategy, which could be a tripping point later for the underground operations. All right. So any volunteers from the panel to start off with this?
Yeah, I think it's a fairly detailed question. I'm trying to sift through it, but I mean, I think it's something that's increasingly we're faced with from open pits going to underground, and particularly to open pits going into caving operations. And so there's a few things to consider. Is you've also got to, in addition to closure of the pit, if you've got the underground underneath it, you have to often maintain the geotechnical performance of the pit and the hydrogeology of the pit to support the underground. So I think how are trade-offs. So I think I think in some operations you can do closure of a pit while still mining underground, and it not normally, if it's a continuous ore body, the ore body is underneath the pit, so probably the last thing you want to do is start to create a pit lake while working underground. But I think I think yeah, so I think the trade-offs with stakeholders, I think yeah, I mean, I think you've always got to look at the protection of the safety and the economics of the underground operation, but there's things you can do with the open pit while still working underground. I mean, I guess a good example is New Afton, where they've actually put tailings and closed the pit while caving underground. That was kind of a decision which made a lot of sense, but it's a balance between getting the pit closed and a efficient underground operation. So I guess it's a complicated question. I hope I've thrown a bit of light on that. Somebody else can have a go at it.
I think could be associated with the type of underground mine operation you have. There's a lot of connection about open pit and underground. So if you are preparing your underground for a caving, for example, you can be can increase the slopes, so you can go further less in your safety, because you will in the end will fail down everything. But if you are preparing a crown pillar or the type of underground operation you are decide to go underground, is totally related with the open pit. So the connection is too strong, and we know very very soon we will have another guidelines exactly about this topic, how to go open pit to underground. So LOP is preparing a guideline exactly on this topic. So it's a very very complicated answer, because depends of what type of ore body you have, water ground association, type of underground operation, if it's caving, block caving, and this type of thing. So it's a long answer for this question. So wait for the interaction underground open pit guidelines that will be next year, if I don't mistake.
Thanks, Tim. That's a good. Good comment. If maybe Julia or Cheryl, could you put the website for the LOP in the chat? So we have that.
So one quick example where there's a couple of projects I've done this for now. When you had an open pit and you wanted to close it as a pit lake, and then they've gone underground, then if the underground access is from downslope, and you maintain the connection between the hydraulic connection between the pit and the underground, then you're left with a decision of whether to leave the pit dry and drain it all out through the underground, or whether to plug the underground and flood the underground and the pit. And of course, if you leave them all open, then you've got lots of water and potentially geochemistry to deal with. But if you plug it and there's quite an elevation difference, then you've got to think about how long is a plug going to last with a large head of water behind it. So it's a complicated question, and there's lots of different facets to it. But that's one that I've been involved with a few projects is when an underground drains an open pit, how do you then deal with the water that would have otherwise accumulated in the pit?
The one part of the question was about trade-off studies with a bigger exclusion zone or a smaller exclusion zone, depending on the, I suppose, aggressiveness of the underground or the open pit mine in late stage mining. I think that the trap that many of us engineers fall into is just boil it down to a straight economic outcome and a factor of safety. Tia was highlighting factors of safety are not a particularly good mechanism to communicating with stakeholders. They want to know about performance and
Did we lose Phil?
I think we did. Yeah.
I could complement it. I would
Yeah.
I agree with Phil. I would say that it's a question of I don't know premises, statements, what agreements it's necessary to the transition from one to another one, from the open pit to the underground. For example, what kind of safety factor, probability of failure, water level, as Jeff mentioned. So what are like the premise, the assumptions to each project? So it's a case by case analysis, I would say. But I mean, regarding, for example, the stakeholders and the trade-offs, I would say that's what are the assumptions necessary from a project to another one to start. And I believe the conversation should start with this kind of assumption to start an underground operation from an open pit.
Thanks, Miguel. Thanks for filling in there. We did lose Phil, so. Any other comments, Jeff or Teo, for this question?
No, I just think, I think what you've got to be cognizant of is if you do put an underground beneath an open pit, it can lead to fundamental changes in the closure approach, and stakeholders have to acknowledge that. There's a good case study in the closure book on Golden Cross in New Zealand, which is exactly how we had to do that. We had to close the pit and the underground concurrently. So that's quite a good case study.
Yes, I just want to point it out. Final thing is relate to be more aggressive when you are in the end of the mine. In generally, you do the contrary, because all the failure mechanisms they're producing during the life of mine are concentrated and more difficult to solve and more cost effective when you are in the end of the mine. So usually when you are reaching the final design of the mine, normally we are less aggressive in order to have the final slope stability. So if you go to open pit for underground, it's a good way to don't need depends of your underground operation, if it's caving or something like this. Maybe you can see you could be more aggressive and let the failure down, because we will have everything in the underground mine. So it still depends of your underground mine operations.
All right. Thank you so much, Teo. And Jeff and Miguel and Phil, who we unfortunately have lost. We are out of time for the webinar today, but I do want to just share a few additional pieces of information. We've mentioned a few times about a book, a new book. So I just wanted to show you what that book is. It is the Open Pit and Waste Dump Closure Book, which is brand new from the Large Open Pit Project. They are the ones who put together all of these texts, who we sometimes base our courses off of these texts. They're very useful. They're put together by industry professionals, so very practical. And this is the newest one, which, as you can see, Jeff and Phil, who are on our panel today, acted as editors. So this is now available at lopproject.com. Also, we're talking about the GCE course, which is Fundamentals of Open Pit Slope Design, where the case studies that Miguel and Teo provided on from Vale, those are within this course, as well as Phil and Jeff's other presentations. So that is starting September 16th. And just very quickly, we have another new course, which is our new 2025 course for the GCE, which is blasting and pit slope performance, which is a new and exciting topic for us. Same format as all of our other courses put together by industry experts. So we're really excited about this course, and we wanted to share that with you. And lastly, thank you so much to our panel. Thank you to our participants. We really appreciate your time today. It was an amazing discussion, and I hope that everyone enjoyed themselves and that our attendees benefited from the conversation. So thank you so much. We will see you again soon, I hope.
Thank you, Jill, and thanks everybody.
Thanks,
Thank you,
everybody.
Jill.
Thank you, Julian.
Thanks,
See
everybody.
you later.
Great
Thank you, Julia.
discussion.
See you soon.